Hi, Alan Stratton from Woodturning. One of the benefits of the Christmas Ornament Challenge is to have inspiration as I look at the ornaments. And you can have the same inspiration as you look at the ornaments that come into the challenge. In fact, there's still time for you to vote in this year's challenge if you get right at it when you see this video. But in this case, Dan Owens submitted an ornament that had been 3D printed and then added wood turnings to it. I thought, well, if he can do it, why can't I? I'll do it my way. He can do it his way. And in fact, Dan, if you see this video, I invite you to make a comment as to what differences there are between the way you did it and the way I did it. So in this video, I'm going to give you an overview of how to design this globe, and then I'll turn a tree to go inside and a finial for the top and the bottom. I made the base wide enough so that I could fit the tree in through the bottom, kind of like an inside-out ornament. So it won't be in-depth training, it'll just be an overview, so don't worry about it being 2 hours long. It's going to be very short and quick. So let's design, print, turn, and assemble this ornament, both 3D printed and turned.
For this project, I'm using OpenSCAD, a free 3D development software. This is parameter and code-based with visual results. This is in contrast to SketchUp, which is a 3D visual workspace with free and paid versions, and Fusion 360, which is more expensive, which is somewhere in between. To start, I want a sphere of 50 millimeters in diameter. Then I can examine the preview to see if I like it. This looks quite faceted, a common artifact of 3D rendering, so I also enter a command to smooth it when it is nearly finished. Next, I want the sphere to be hollow with a certain wall thickness, so I set up a command to subtract a sphere from the outer sphere. While I'm at it, I stretch the sphere 50% more in the vertical direction. The only problem is that I cannot see that it is hollow yet. Since this will be a globe-style ornament, I want holes for the top and bottom finial. For this, I add a couple of variables that I can adjust later as needed. Using variables enables me to change the result without extensive redrawing. This goes inside the subtraction structure. Manipulating the preview, let me confirm the result. To beef up the lower hole, I created a hollow cylinder, then adjust where to place it in the vertical dimension. That looks good. The next part is more complicated. I want a shape that I can use to create a diamond-shaped hole in the globe. This is in a module that can be used over and over again with slight differences in width and height. With the reusable module finished, I can place it into the code. In this case, I only need to incline or decline it from the center of the globe. Now I add another parameter for 16 repetitions and loop code. Then fiddle with parameters until it looks good. This is starting to look okay. Next, I add 5 more variations of the same module and fiddle with the parameters until I like the result. I am finished with the design, but there are more steps required. So far, I have been previewing the globe, which is a quickly generated approximation of the result. I need to officially render it into a 3D file and save it to my disk. Fortunately, this is one keystroke to render, but takes longer to generate. If you look closely, there are smaller but more facets. This will not be noticeable in the final result. To print the result, I first have to import the 3D file into a slicer program that takes the 3D object and literally slices it into layers. I'm happy to let the computer do this since it is a complicated math and very tedious to do manually. Here I can also sample inspect layers as necessary, then save the printer code onto an SD card and move it over to the 3D printer. The program reports that with layers 2.2 millimeter high, this will take almost 3 hours to print and use 9 grams of PLA filament. The print file is over 7 megabytes of printer commands that I never bother to look at. At the printer, I load natural color PLA filament, which is plant-based, and start the printer. After heating the printer nozzle to over 200 degrees centigrade and the printer bed to 75 degrees, the printer starts wiggling and squiggling layer by layer. I can inspect periodically to see if it is going well. This type of projects takes some fiddling to succeed. Now to add some pizzazz to this ornament, I envision a tree to go inside the printed shell. I choose a piece of scrap mesquite and rough it down to about 1 inch, small enough to go inside the bottom of the ornament. Then, eyeballing the shell against the wood, I can mark the top, bottom, and branches. Then mark these points with a parting tool. Then start whittling it down with my skew. As the surface approaches the final tool grooves, I deepen them a bit more. Then back to the skew. Then the top gets thin and takes a fire. No problem, I already have a trunk that can serve as a tenon. Then mount it to my long-nosed jaws to cut off the remaining top. Finally, sand and apply shellac friction polish and rub it out. Now for a top finial. I need a tenon to fit the top hole. With the tenon fitted, I proceed to cut a simple shape, then sand and apply shellac to the finial. But this top finial is not quite finished. Remember that tenon to fit inside the top of the globe? It will serve me well as a mounting tenon while I drill and finish the tippy top. Now for the bottom finial. This is the same piece of birch that the top finial came from. First, get rid of some wood that is too small to fit the bottom hole. Then move on to cutting a tenon to fit the bottom hole of the globe. Then, since I cut it a trifle too small, I move up the piece of wood a little more and cut it again. Then I can drill a mounting hole to fit the trunk of my mesquite tree. Then, with the wood stabilized with a comb center, I can move on down the piece to form the bottom finial. First, I want to dramatically reduce the diameter so that it will not look too blocky. This time, I will use my spindle gouge. I work it down with some simple curves. After sanding, I can apply shellac friction polish to the finial. Then reverse the finial so that I can fine-tune the bottom tip. After cutting off some excess hollow wood, this finial takes fire. This is the day in my shop for finials to fly. Not much of a surprise since the tenon is only 1/8 inch long. After a little more with my tools, I decide to finish with sandpaper, my 120 grit gouge. Then move on to finish sand and apply shellac. All that is left is to glue the pieces together and add a hanging loop to complete my multimedia ornament. It is a nice combination of 3D printing and wood turning that will hang well on a Christmas tree. Please give this video a thumbs up, subscribe on my website, and tell your friends about my videos. I appreciate your comments and questions. Every week, I add a new wood turning video to my website. Always, please wear your full face shield anytime the lathe is running. I harp on this because a face shield saved my life.